discussed what are salts. Okay. What are salts chemically? What is a salt chemically? We have already discussed that it will have any cationic part, any anionic part, right? And both of them will combine together, provided the cationic part should not be H plus and the anionic part should not be OH minus. If the cationic part is H plus, that means it's an acid. If the anionic part is OH minus, that means it's a base. And if both H plus and OH minus are together, clearly that will form water. Fine. So the point here is that this is salt, any cationic part, any anionic part, except H plus and OH minus respectively. That will give us salt. Now see, how are salts actually prepared? How are salts actually prepared? So first, can you write the formula for potassium sulfate, sodium sulfate, calcium sulfate? All of you, please write that formula very quickly. Magnesium sulfate, copper sulfate, sodium chloride, sodium nitrate, sodium carbonate, and aluminum chloride. All of you. Saad, beta, turn on the camera. Saad, what will be the formula for potassium sulfate? Can you tell me that? Yes, all three of you have done for potassium sulfate. Fine. Afshin, bachi, turn the camera. Saad, are you present in the class? Fine. So alpha, potassium sulfate. What will be the formula? K2SO4, right?
K2SO4, yeah.
Fine. Sodium sulfate.
Sodium sulfate Na2SO4.
Excellent. Calcium sulfate, Ca2SO4.
CaSO4.
CaSO4. Excellent. Magnesium sulfate.
MgSO4.
Copper sulfate.
CuSO4.
USO4. So here copper is present in which state? +2, +1.
+2.
+2. Had this been present in the +1 state, the formula would be Cu2SO4, right?
Yeah.
SO4, fine. Sodium chloride.
Sodium
NaCl.
Na2NaCl.
Then how Na2? Cl is -1. Sodium nitrate, no worries. Sodium nitrate, Na. What is the charge on nitrate? NaNO3, sodium nitrate. Okay, charge on nitrate is -1, NO3 -1, that is nitrate. Sodium carbonate.
Sodium carbonate, Na2CO3.
Excellent. Aluminum chloride, ammonium chloride. Important.
NH4Cl.
H4Cl. Okay. Now these are some of the examples of the salts. Each of the compound here, these are some compounds. Obviously, these are some compounds. Okay. Now each of the compound here has got some the cationic part, okay, which is positively charged, and some anionic part, which is negatively charged, and both of them are bonded together, right? Both of them are bonded together. If you are able to recall any neutralization reaction or any reaction in which the salt was being formed as the product, what is the reaction that will give you salt as the product? Can I say it is an acid and a base combining together to give you the salt?
Yeah.
Acid base together gives you a salt, right?
Salt.
Acid base
Yeah.
together gives you a salt. Therefore, what are we saying? That salt is made by the combination of the cationic part of the base and the anionic part of the acid. Salt is made from the cationic part of the base and the anionic part of the acid. How? Let's see. Let's take the example of any acid. Let's take HCl, right? And let's take sodium hydroxide. This is a simple neutralization reaction in which acid is reacting with the base. Therefore, the salt would be formed and water would be formed, right? So NaCl
Yeah.
was here along with water. Yes. So Na here is the positive part we know. Cl is the negative part, right? Na has been taken from the as the cationic part of the base and Cl has been taken as the anionic part of the acid. Do all of you agree with that?
Yes.
Right? So basically the point is it is some combination of an acid and a base which will give you a salt. It is some combination of any acid or a base that will give you a salt. Now, when we need to study the properties, the chemical properties of the salt, we will have to study or we will have to know the properties of the acid and the base which is combining together to give you that salt. It is the properties of the acid and the base which is combining together to give you that salt that will decide the properties of that salt. Yes. Example
Mhm.
C. The important point here is that pH of the salt. How we will know the pH of the salt or salt? What is pH of the salt? What does pH tell you? pH tells you the concentration of H plus ions, right?
H plus ion. Yeah.
Yes. Less the H plus ions concentration, what will be the effect?
More will be the acid concentration.
Less the H plus concentration, not the
Sorry,
pH
more will
value.
be the pH. More will be the pH.
More will be the pH, okay? More will be the pH, that means more is the basic character, right?
Basic.
Simple.
Yeah.
More pH, H plus concentration, less pH value, that means more acidic character. Simple, right? So how do we
Yeah.
get to know the pH of the salts? How do we get to know the pH of the salts? It is assumed that salt will have a pH of 7. That is, salt will be neutral, right? Salt will be
Yeah.
neutral. Now let's quickly take this example. HCl plus NaOH. We'll go with the basic example. HCl is a strong acid. We have already discussed this, that HCl is a strong acid, right?
And then
NaOH is also a
strong
strong base.
base. Yeah.
NaOH is also a strong base. Now, since both of them are strong, therefore NaCl will be having a pH of 7. Why? Because the strong acid is neutralizing the strong base here. Yes, the strong acid is neutralizing the strong base here. Therefore, therefore, therefore we will get a salt which will be neutral because both of them were strong. Therefore, both of them cancel each other's effect equally. Both of them cancel each other's effect equally. Is it clear? Let's take the second
Yes.
example. Let's say I have uh, I have acetic acid. What is the formula for acetic acid? CH3H OH CH3
CH3
COO
C double OH.
CH3 COOH. Now this is an acid. We know this is an acid. Okay. Now if I combining with sodium hydroxide. Now see, there are two scenarios here. Here there's an acid which is a weak acid. Here there's an acid which is a
Weak acid.
weak acid. But there's a base which is a strong base. But there's a base which is
Strong
a
base.
strong base. We will get the salt. What will be the salt here? I've already discussed this example multiple times. What will be the salt here? Sodium acetate, bachcho. Sodium acetate, right? Simple.
CH3
The cationic
COONA.
part, yes, the cationic part, that is the metal, positive metal, okay, metal ion from the base will replace the H plus ions from the acid. Simple. We will get the salt, right? What is happening here? This is the cationic part, which is nothing but the metal ion. It is replacing the H plus ions in the acid, right? We are getting the
Yeah.
salt, right? So now this salt, this is also a salt, but what will be the pH of this salt? Both, all of you, what will be the pH of this salt? Think
7.
and then answer. How? The acid is a weak acid, but the base is a strong base. Don't you think the pH of this salt will be
Base.
towards more of the basic side?
Base.
The basic character will be strong here, right? Therefore, the pH of this will be slightly above than 7. Are you getting it?
Okay.
Okay. Now let's take the third example. So this is the first example where both of them are strong acids. Okay. This is both of them are strong acids and bases. This is the second example where there's a weak acid but a strong base. Okay.
Base.
Let's take the third example. Okay. Let's say I have HCl. I have HCl. Okay. And then I have Ammonium hydroxide. Ammonium hydroxide is not a very strong base. HCl we know is a very strong base. Okay. What's the salt that we are getting here? What's the salt that we are getting here?
Ammonium
Ammonium
chloride.
chloride. Ammonium chloride. Now here there's a strong acid but a weak base.
Okay,
Strong acid
so it will be
but a
more
It
acidic.
will be
exactly
-7.
minus, but it towards 7, less than 7. Okay,
Yeah.
fine. I get your point. Just correct that term. That is less than 7. Are you getting all of this? The
Yes, ma'am.
salt will also, the pH of the salt will be dependent on the type of the acid and the base which is combining together to give you that salt. The pH of the salt will be dependent on the type of the acid and the base which is combining together to give you that salt. Okay. Quickly, I'm giving you that example. Carbonic acid, carbonic acid, along with carbonic acid, along with potassium hydroxide. Carbonic acid along with potassium hydroxide. Sorry. Carbonic acid along with potassium hydroxide. Very quickly, बच्चों. Carbonic acid along with potassium hydroxide. Excuse me.
Ma'am,
Just a second. Just a second. Yes. Sorry. Yes. Question was regarding the carbonic acid and potassium hydroxide, right? What's the salt that you get?
potassium carbonate.
Potassium carbonate. Can you tell me the this thing, the pH of potassium carbonate
It will be more towards the base.
towards the
Base.
base? That is, I mean, the pH value will be slightly more than 7. Yes, the
Yeah.
basic character will be more here. Correct. Now, very quickly, last example here: sodium hydroxide, sodium hydroxide, and carbonic acid. Sodium hydroxide and carbonic acid. Saad, I hope you are doing these questions.
Yes, ma'am.
Yes, बच्चों.
Ma'am,
Mm-hmm.
sodium carbonate, and it will be more towards the base again because sodium hydroxide
Exactly.
is a strong base.
Excellent. Okay. So we will get sodium carbonate. Now the reason is that many a times this question is asked many times, why is it advised to not use sodium carbonate but rather to use sodium bicarbonate? Okay. And the reason here is that because sodium carbonate, although is a salt, but is a stronger, I mean, is a salt which is more basic in character, right? So that will have the effects more like a very corrosive. It can also be corrosive at times. Okay, that is why many, I think there's this question in the NCRT exemplar that if the hand is burned through acid or something like that, what should be applied? The option says whether sodium carbonate should be applied or sodium bicarbonate. Sodium carbonate is equally strong, right? Because it is equally strong basic salt. Therefore, that will also have the same effects. Therefore, stronger base should be avoided, and salt which is not very acidic, which is not very basic, should be applied, and that is sodium bicarbonate. Okay, I hope that the concept is clear. And
Yes,
if we see about sodium bicarbonate, see how is it less acidic, I mean less basic here than sodium carbonate. See, it has got one H plus ion also. Therefore, the basicity character has been decreased in this salt from sodium carbonate, which has no H plus sign. Are you getting it? The basicity
yes,
character
ma'am.
has been decreased here. Therefore, this is more towards a neutral salt. The pH of this salt is more towards a neutral salt, although this is slightly basic, very slightly basic, enough to neutralize the effect on the skin of any acid, but also not very corrosive. I hope the concept would be clear. Any problem here?
No, ma'am.
So potassium carbonate will change the litmus from potassium carbonate. Very quickly on your tips. Potassium carbonate will change the litmus from red to blue or blue to red?
Red to blue.
Red to blue. Sodium acetate will change the litmus from
Blue to red.
sodium acetate. Stronger base, weaker acid.
Oh, then red to blue, yeah. Red
Red
to
to
blue.
blue. Okay, red to blue. Ammonium chloride will change the solution. Mind it, here we are always talking about the solutions. Okay, the solution of ammonium chloride will change what litmus to what color?
Blue to red.
Blue to red. Excellent. Strong acid, weak base. Fine. Afshin, let me know if there's any confusion here.
No, ma'am.
Saad, I know you're not much attentive today, but let me know if there's any confusion.
Yes, ma'am.
Fine. Salts of a strong acid and strong base are neutral with pH value of 7 as discussed. Can you quickly give me one example of a salt with pH 7? Hmm. Yes, bachcho. Example of a salt with the pH value of 7.
Pure water.
How is that a salt?
Okay.
NaCl, continuously discussed. On the other hand, salts of a strong acid and weak base are acidic with pH values less than 7. And those of a strong base and a weak acid are basic in nature with pH more than 7. So these are three combinations that we can have. Strong acid, strong base, pH value 7, that is neutral, okay? Strong acid, weak base, less than 7, more than 7,
Less than 7.
less than 7. Weak acid plus a strong base, more than,
More than
Then
7.
these are examples here, okay? And accordingly, the question could be asked on the basis of the pH, what will be the change in the litmus paper? So that should be very clear here, okay? Although through these examples, I've discussed the examples of weak acids and weak bases, the strong acids and the strong bases. If you would want to write some of them, let me know. I'll dictate them.
Yes, ma'am.
Okay. Strong acid. Afshin Bache, write it for strong acid. Should I say that?
yes, ma'am.
HCl, H2SO4, HCl, H2SO4, HNO3. Yes, Bachos. HCl, H2SO4, HNO3. What's the name of HNO3? Nitric acid. If you don't know the names, please write it down. Nitric acid, HNO3. Okay. Coming on to the weak acids, Bacho. Should I dictate? Afshin?
I have written for weak acid.
Weak acids you have written? Carbonic
Yes.
acid, H2CO3, acetic acid, benzoic acid. Okay, all of these are examples of weak acids. Carbonic acid, although is a mineral acid, but it's a weak acid. Be mindful of that.
Ma'am, can you repeat the weak acid?
Yes. Carbonic acid, H2CO3.
Ma'am,
Then acetic acid.
H2CO3 is sulfuric acid.
Bachche, carbonic acid. I'll write it here. No worries. Wait. Strong acids, I'll write. Weak acids, C. H2SO3, H2CO3, that is carbonic acid. Okay, H2CO3, carbonic acid. CH3COOH, acetic acid. Okay. This is enough. Just for the example part, you can write benzoic acid. No need to go for the formula. Okay. Benzoic acid. Fine. Okay. These are weak acids. Strong acids already dictated. HCl, H2SO4, that is sulfuric acid. Okay. HNO3, nitric acid. Clear? Now strong bases. Strong bases. Can you tell me what will be the examples of strong bases, bachcho?
Sodium hydroxide,
Mm-hmm.
zinc hydroxide,
Zinc, potassium hydroxide, lithium hydroxide. Okay, that's it. Come on to the weak bases. Ammonium hydroxide. Very important. Done. Yes, last turn I discussed whether magnesium hydroxide is a strong base or a weak base.
magnesium
I want to know,
hydroxide is a strong base.
very strong base. Is it a very strong base? What's the pH for magnesium hydroxide? Already discussed in the last turn.
It's slightly 7.
It's slightly.
No.
Whatever you said is like doesn't make any sense. Okay, I'm glad that you corrected that. But so magnesium hydroxide had a pH of around 10,
10.
and that is not very strong basic. I already told you that is not very strongly basic, right? Therefore, magnesium hydroxide. All the less reactive metals will give you weak bases. Fine. Good done. These are three very strongly reactive metals: sodium, potassium, lithium. Therefore, you will get very strong bases for them, right? Weak bases. Clear? Any problem here? Tad, if I ask you to react ammonium hydroxide and nitric acid, leave nitric acid. If I ask you to react uh, magnesium hydroxide and sulfuric acid, magnesium hydroxide and sulfuric acid, tell me the product with the pH. Magnesium hydroxide and sulfuric acid.
And what was the formula for sulfuric acid?
Bachche, H2SO4. H2SO4.
2SO4.
Yes. Now the formula should be on tips, especially these. Then, bachcho, just let me
Ma'am,
know what. Just a second, Asa. Just let me know. Will the litmus paper be changed from red to blue or blue to red?
And it will change from red to blue.
Okay, red to blue. I take your answer. Fine. Any other answer? Arfa, Afshin, bachcho. Any other answer? Saad, you said it should change from red to blue. That means I should assume that you are saying it is basic, right? That is why it is changing from red to blue.
Yes, ma'am.
Correct? Fine. I take your point. Arfa and Afshin, any answer here?
No, ma'am.
Afshin, although I'm expecting an answer from you. Ma'am.
Ma'am, blue to red.
Blue to red. That means you are saying it's acidic, right? That means
Yeah.
you are saying it's acidic. Sulfuric acid is a strong acid already discussed. Magnesium hydroxide is a
It's a
weak base.
weak base. So
Okay.
it will be
Now,
more towards acid.
excellent. Now, what will be the formula of the salt that we are getting? Saad, Arfa, don't say that. No. Saad, what is the formula that we are getting here? If we are reacting sulfuric acid plus magnesium hydroxide, yes. What's the formula that we got here? I've already discussed as to how to get the formulas for salts, right? I've already discussed that. We'll just replace the H plus part of the acid through the metal ion.
And magnesium
Keeping in
sulfate.
yes, yes. Let me know of the formula here. What's the formula for magnesium sulfate?
MgSO4.
MgSO4. Is it correct? Afshin, is the formula correct for magnesium sulfate?
Yes.
Yes. Alpha, is it correct?
Yes, ma'am, it is correct.
Yes, it is correct. But it is
Acidic.
and not basic. बच्चे साथ see H2SO4 is a strong acid, okay? MgOH2, that is magnesium hydroxide, is a weak base. Therefore, which will have a stronger effect? Definitely, it will be the acid having a stronger effect. Now, if the acid is having a stronger effect, definitely the pH will be towards acidic, right? That is, the pH will be less than 7. If the pH is less than 7, definitely the litmus would be changing from blue to red, right? I hope the concept has been understood. Fine, moving on to the next part. Now, how are we going to use the salts, okay? And through different procedures, we'll get different types of compounds, basically different salts, okay? Fine. So this topic is very important. This is although a very factual topic, but most of the questions are framed from this topic, fine? So, already learned that salt formed by the combination of hydrochloric acid. Yes. So salt formed by the combination of hydrochloric acid and sodium hydroxide is NaCl, which is also called as the common salt. Okay, sodium chloride, common salt. Alpha, Sat, turn on the camera. Called the salt that is used in the food. Fine. Now see, neutral salt. Why is it a neutral salt? Saad will answer this at the end of the class. Seawater contains many salts dissolved in it. Sodium chloride is separated from these salts. Deposits of solid salt are also found in several parts of the world. Fine. Let's know, like this is seawater, okay? As already discussed in the previous classes, especially in the ninth standard, that seawater has got many salts, right? Which is present in more of a homogeneous form. So when seawater has got many salts, basically what do we do is that we try to separate the salt, which is most of our, it has very prominent uses for us, and that is NaCl. So through different procedures, also called as desalination of the seawater, we get NaCl, okay? Now, once we have gotten NaCl, what can we do from this? Let's see. Is this part understood? Is this part understood?
Yes.
Yes, ma'am.
Fine. See. Now, deposits of solid salt are also found in several parts of the world. What do we mean by solid salts, basically? Basically, these salts we are getting in the form of from seawater, right? So definitely they are first found in the liquid form and then we extract them, right? Through different procedures like evaporation. Now, there are some minerals. I hope you all are aware of the term minerals, okay? Now, there are some minerals in which we get these salts. Rock salt is what? Rock salt is nothing but a mineral, okay? And we get that salt from that mineral, okay? Rock salt is an example of a mineral. Clear? Fine. Moving on to the next part. These large crystals are often brown due to impurities, obviously formed. This is called the rock salt. Rock salt is an example of a solid salt, okay? Beds of rock salt were formed when seas of bygone ages dried up. Rock salt is mined like coal because it's a mineral again, okay? Any confusion in this paragraph? Moving on to the next one. Fine. Mahatma Gandhi's Dandi March. Did you know that sodium chloride was such an important symbol in our struggle for freedom? Important point. How was that? How was the salt extracted? What was the point of this march, Dandi March? Hmm. What was the point of this point in this Dandi March?
Man, they want the Britishers to allow them to make salt.
Yes, they wanted them. They wanted to make their own salt, right? And how did they do this? What was the procedure here? Now I've just discussed this point. How can we get the salt from the seawater?
By separating iodine chloride from the seawater, sodium chloride,
Huh.
sorry.
Uh-huh. And how do we do that? Simple, in simple words, evaporation, right? What are we doing? We are evaporating. Let's say we have taken some amount of the seawater. Water will definitely get evaporated. What will be left behind? That will be the salt. We can purify that to get NaCl here. So you should be aware of these things. Fine. Now, common salt, already very important for our diet and also very important for the industrial purposes. A raw material for other chemicals. Raw material for other chemicals. Be very clear with the formula and the formation of NaCl. Very clear with this. Fine. Common salt thus obtained is an important raw material. Sodium hydroxide, baking soda, washing soda, bleaching powder, and many more. Quickly write down the formulas for all of these compounds. Quickly, sodium hydroxide, baking soda, washing soda, very quickly. Yes. Written, sodium hydroxide. What's the formula? Saat bache. Sodium hydroxide. You should know it by now.
NaCl2.
Bache, NaOH. Baking soda. Baking soda, important.
I don't know for it.
Please keep on writing these if I'm writing it here. Sodium hydrogen carbonate, also called as sodium bicarbonate, is nothing but baking soda. Okay. Washing soda, sodium carbonate. Okay. Sodium carbonate is washing soda. Bleaching powder, important. Bleaching powder, CaClO whole twice. CaClO whole twice. Okay, should I write it again? CaClO whole twice. Okay. Calcium hypochlorite. Write the chemical name, calcium hypochlorite. Okay. The chemical name for bleaching powder is calcium hypochlorite. Now these should be clear because that is what we are going to discuss. All these that we have discussed here, we are going to discuss all these. Okay, the formation of all of these compounds. Fine. Sodium hydroxide. How is sodium hydroxide formed? Aqueous solution. Let's say that we have taken NaCl in the aqueous form. Okay. NaCl has been mixed with distilled water. That will give us the aqueous form of this NaCl. Okay. And this is called as brine. This is called as brine. Okay. Aqueous solution of sodium chloride is called as brine. First important point. Aqueous solution of sodium chloride is called as brine. Tad, is there any confusion? Because I can clearly sense some confusion on your face. Any problem? Anything that you're not getting? Am I going too fast? What is the problem?
No, nothing.
Fine. Is it okay with all of you? I hope I'm not going very fast.
No, no.
Fine. Now, what happens? This is in the aqueous form. When this decomposes, decomposition I have already learned in the first chapter. Okay. This will give you sodium hydroxide. This will give you sodium hydroxide. Now be clear with the formulas. NaOH means sodium hydroxide. Okay. It will give you chlorine gas and it will give you hydrogen gas. The decomposition of the brine, that is the aqueous form of sodium chloride gives you sodium hydroxide, gives you chlorine gas, and gives you hydrogen gas. Is it okay? This is the first chemical reaction which is very important. Fine. Clear? Now, what happens? Chlorine gas is given off at the anode and hydrogen gas at the cathode. What does this mean? That it has been decomposed through the electrolysis process. Through the electrolysis process. I think we have discussed this in detail in the first chapter. What is electrolysis, right? Saad, Afshin, respond. But you respond. It's not going to work like this.
Yes,
Fine.
Yes.
Now, hydrogen gas has been given off at the cathode and chlorine gas given at the anode. Be mindful that the anode is positively charged. Write it there. Chlorine is given off at the anode because anode is positively charged. Therefore, chlorine being negatively charged is attracted towards the anode. Write it. Hydrogen gas was positively charged in the form of H+. Therefore, it is attracted to the cathode, which is negatively charged. Okay, in the gaseous form. The sodium hydroxide is present in the aqueous form in the container, in the setup, okay, in the experimental setup. Fine.
Ma'am, can you explain this again?
Yes, what?
Ma'am,
Chlorine is
the
negatively charged. Chlorine Cl minus is negatively charged. Therefore, it is deposited as the anode, which is positively charged. Okay. Hydrogen, which was positively charged, is deposited in the form of H2 gas at the cathode, which was negatively charged. Clear?
yes, yes,
Fine.
ma'am.
Moving on to the next one. Should I start with the next point, Arfa and Sar?
yes, ma'am, done. Yeah.
Fine. Now, sodium hydroxide solution is formed near the cathode. We'll see why. The three products produced in this process are all useful. What are the three products in this process? Electrolysis of aqueous sodium chloride is giving us sodium hydroxide, chlorine gas, and
Hydrogen gas.
Hydrogen.
hydrogen. This is the setup. The chlorine gas, why is it useful? It is used in water treatment, swimming pools, PVCs, disinfectants, CFCs, pesticides. What are CFCs? Chlorofluorocarbons. Chlorofluorocarbons, write the full form. Chlorofluorocarbons. And very commonly used in refrigerators and the ACs. Chlorofluorocarbons, the major cause of ozone depletion. Done. Write the full form of PVC. Polyvinyl chloride. It's a polymer. Polyvinyl chloride.
And chlorofluorocarbon is major form of?
Ozone, a major cause of ozone depletion. Major cause of ozone depletion. Okay. Two important points that I wanted to discuss here in this diagram. Moving on to the next. See. Should I? These are two important full forms that I wanted to tell you here. Now, coming on to the bleaching powder. Once we have gotten these three products, that is sodium hydroxide, chlorine gas, and the hydrogen gas, let's see how are they actually used. Chlorine is produced during the electrolysis of aqueous sodium chloride, that is brine. First point. This chlorine gas is used for the manufacturing of bleaching powder. Now be careful with the formula of the bleaching powder. Bleaching powder is produced by the action of chlorine on dry slaked lime. What is slaked lime? I've already told you calcium hydroxide. Yes, calcium hydroxide is slaked lime. We have taken that in the dry form and we have actually passed the chlorine gas which we got from the decomposition of the sodium chloride through this slaked lime. Okay, what we will get? Calcium hypochlorite here, that is the bleaching powder. Okay, calcium chloride and water. Calcium hypochlorite, that is the bleaching powder. If you have your NCRTs, I would suggest write the chemical names and the common names here. Okay, calcium hydroxide, first reactant is बच्चे calcium hydroxide. Calcium hydroxide, and the common name here is slaked lime. Clear? Calcium hypochlorite. And the common name bleaching powder. Any problem? Saad, Afshin, any problem, bachcho?
No, ma'am.
Fine. Saad, have you written this? Should I repeat this again? CaClO2, CaClO whole twice, okay? The chemical name is calcium hypochlorite. Calcium hypochlorite. Calcium hypochlorite. At last, it is Te and not De, okay?
Ma'am, the
And
chemical form equation is different in my exactly.
just a second, I'm coming to that. And bleaching powder is a common name for this. Yes, Afshin, what's the problem?
Ma'am,
Yeah,
the
ma'am, it's even
equation is
different for me.
different for
What is it?
my
What is it?
it is the reaction is CaOH2 and then Cl2 it gives CaOCl2 H2O equals 2.
Yeah,
Okay, okay, okay. See, OCl2 or ClO means the same thing. Ultimately, the formula will get the same. Basically, you are saying that it is written like this, CaOCl, right?
yeah,
What's the difference? I will still say that it is CaOCl whole twice. That means in this I am having one calcium atom, two oxygen atom, two chlorine atoms. In this also I'm
it's
having
the
the same
same
formula.
thing.
Yep, hypochlorite. That's it, simple. Any confusion here, Afshin and Alpha?
No, ma'am, no.
No, ma'am.
Sad, is it clear? How do we get this? How do we get the bleaching powder? And what is the component from the electrolysis of sodium chloride that is actually useful for the production of bleaching powder? What is the component from the decomposition of sodium chloride which is useful in the production of bleaching powder? Answer, bachcho, answer. Chlorine, it's Cl2 gas, already discussed. Moving on to the next. Bleaching powder uses. Bleaching cotton and linen in the textile industry. Bleaching wood pulp in paper factories for bleaching washed clothes and laundry. As an oxidizing agent, this is the chemical use, please look onto this. As an oxidizing agent in many chemical industries. Why can it be used as an oxidizing agent? Yes. Why and how can the bleaching powder be used as an oxidizing agent? Yes,
Because it has oxygen.
it has oxygen, right? Oxidizing agent will really release this oxygen atom to other compounds, therefore it will act as the oxidizing agent to make drinking water free from germs. Again, the same purpose of basically as a disinfectant, okay? Moving on to the next part, that is baking soda. Write the formula here. Write the formula here for baking soda very quickly. What is the formula for baking soda? Sodium.
NaHCO3, sodium
NaHCO3.
hydrogen carbonate.
Sodium bicarbonate, sodium hydrogen carbonate, NaHCO3, NaHCO3, okay? And now tell me the acid and the base which is used to form this, sodium hydrogen carbonate. Acid and the base used to form this. I've discussed this.
Carbonic acid is used here and sodium as a base is used here.
Sodium hydroxide, right? Sodium hydroxide is a base. Fine, good. The baking soda is commonly used in the kitchen. Sometimes it is added for faster cooking. The chemical name of this is sodium hydrogen carbonate, NaHCO3. It is produced using sodium chloride. See, we got 3 products there. Out of that, let's see how sodium chloride is used here. Although sodium chloride as the raw ingredient. We have NaCl, okay. We have it in the aqueous form, H2O. We pass CO2 through it. We pass ammonia through it. What is it? Ammonia, NH3, okay. We will get ammonium chloride along with sodium bicarbonate. We will get ammonium chloride along with sodium bicarbonate, okay.
Ma'am, what's the state of ammonium chloride?
Ammonium chloride, solid, bache, salt.
Solid, okay.
Okay. If it is present in the aqueous form, like if water is still there, okay, it will be in the aqueous form. Otherwise, if you ask in the general state of ammonium chloride, it's a salt, it will definitely be in the solid form, okay. I hope it answers your question. Fine. Next point. The pH of sodium hydrogen carbonate. What will be the pH of sodium hydrogen carbonate? Towards more than?
Acid.
Uh-huh. Carbonic acid is a weak acid.
Then base.
Then base. Very, very, very slightly basic. Okay, it's very slightly basic. Fine. Why it can be used to neutralize an acid? Yes, because it's a mild, non-corrosive basic salt. See again, it's a mild, non-corrosive basic salt. Sodium carbonate is slightly corrosive, therefore it cannot be used on the skin. Okay. See, as sodium bicarbonate is heated, what is this? Heating is what? Decomposition. Simple decomposition, right? Thermal decomposition is taking place here. When we have thermal decompositions for sodium bicarbonate, we will get sodium carbonate, bachcho, water and carbon dioxide. Sodium carbonate and water and carbon dioxide. Any problem here?
Ma'am, what's the sodium carbonate here? Is it a salt?
Yes, bachche, sodium carbonate is a salt.
Okay.
See, it is having positive and negative salt. We discussed this. Sodium hydroxide plus carbonic acid will give us sodium carbonate. What is the confusion till this point? I can sense some of the blank faces sitting here, huh?
No.
No. Afshin, Saad, everything is clear. Sodium hydrogen carbonate has got various uses in the household itself, okay? For making baking, see, baking powder and baking soda is different. What we use in the household is a baking powder in the kitchens, okay? Generally, that has been used. Now, baking powder is actually made from baking soda, but there's slight difference in them, okay? The composition is different. For baking powder, which is a mixture of baking soda and a mild edible acid such as tartaric acid. Very important. A mild acid, which is edible, obviously, plus baking powder, plus baking soda will give you the baking powder. Write it. Write it. If you want, you can write it. Okay. When baking powder is heated or mixed in water, the following reaction takes place. We are going to discuss this. Write it. Done. Now, sodium bicarbonate, which is a salt, very mild, non-corrosive salt, basic salt, okay, and H plus because this is already present in the form of a mild edible acid, right, in the baking powder. Now, when this reaction will take place, salt, carbon dioxide, and water will be released. What type of reaction is this? We have already studied this very quickly. What type of reaction is this? We have studied
Decomposition.
this. Uh-huh. Arfa. What is getting decomposed here? We have studied this reaction. And I told you then just by looking at the reactants and the products, you can get to know the reaction. And we have the reactants and products, both of them here. Tell me the reaction, bacho.
Neutralization reaction.
Neutralization
No.
reaction. Tell me this one thing very honestly. Are you all studying this after the classes? Sada, did you study this chapter after the classes? Yes or no?
Yeah, 1 or 2 times.
Huh?
1 or 2 times.
1 or 2 times. Afshin, did you study this?
Yes.
This is a simple reaction of a metal bicarbonate or metal carbonate reacting with any acid to give you the salt, the water, and the carbon dioxide gas. Moving on to the next point. Carbon dioxide produced during the reaction can cause the bread or the cake to rise, and this is the same phenomenon that we use, the reason as to why do we use the baking powder, okay? This is the same reason. Sodium hydrogen bicarbonate is also an ingredient in the antacids. Why is it an ingredient in the antacids? Excellent question. Why?
Because it's a strong base.
How come is it a
No,
strong
no,
base,
no.
but it's a
No.
mild base?
Yeah.
It's a mild basic
Yeah, it's a
salt,
wild
okay?
base, that's why.
Salt, yes. Then how is it and why is it used in antacids? What are antacids? Antacids are compounds that are used to reverse the effect of high acidity, right?
But
We
yeah,
need to neutralize excess of the H plus ions, which is causing higher acidity. If we need to neutralize that, we need to have a mild basic salt there. Therefore, sodium hydrogen carbonate is used in that.
it
Is it clear?
neutralizes the hydrochloride.
Not hydrochloride, but we are not concerned with the hydrochloride. We are just concerned with the H plus ions concentration, okay?
Okay.
Being alkaline, it neutralizes excess acid in the stomach and provides relief. Same concept. It is also used in soda fire extinguishers. Why is it used as the soda fire extinguishers? Because through the reaction we can have CO2, right? We saw that, right? Through the reaction of the sodium bicarbonates with the mild acids, we can have carbon dioxide, and this is used to basically stop the fire or whatever we have. Okay, is it clear? Coming on to the washing soda. Now, another chemical that can be obtained from sodium chloride is washing soda. Sodium carbonate dot 10H2O, decahydrate. Okay, write it. You have seen above that sodium carbonate can be obtained by heating baking soda. That was the first part. Recrystallization of sodium carbonate gives washing soda. Recrystallization simply means there are some compounds which are attached to some of the water molecules, some specific number of water molecules. Okay, and those water molecules basically are attached to give the crystal form to that compound. Okay, when 10 molecules of water are attached to one molecule of sodium carbonate, the compound will get crystallized. Okay, therefore how many water molecules are here?
20.
Asha, how come are the 20 bache? I did not ask for the number of hydrogen atoms in 10 molecules of water. I simply asked how many water molecules are there, and it is simply 10 bache.
Okay. Sorry.
No worries. So this is also called as the water of recrystallization. The answer for the water of recrystallization for sodium carbonate is 10. Okay, decahydrate. Deca means 10. Should I move on to the next point? Go through the uses of this. I'll discuss it. 10H2O, what does it signify? We will address the question in the next section. Basically, this is nothing but the water of recrystallization. I've already told you this. Sodium carbonate and sodium hydrogen carbonate are useful chemicals for many industrial processes as well. What are those? Okay. Sodium carbonate is used in glass, soap, and paper industries, obviously for the various purposes. Used in the manufacturing of sodium compounds such as borax. Sodium carbonate can also be cleaning agent, domestic purposes. Yes, most of you have seen this, for removing permanent hardness of water. Simple. Okay. You will have to learn some of the uses here. Fine. Now, are the crystals of salt really dry? I will discuss this in the next class, inshallah. We will need one more class to finish this chapter. We'll discuss this last topic. And in the next class, inshallah, if you people allow me to do that, I want to discuss the questions. If you people would be prepared with at least some of the concepts, we'll be discussing some questions, okay? And that will
Ma'am,
be useful for
related
you.
to this chapter, acid bases.
Yes, obviously. But yes. Okay, we'll be discussing the questions related to them. Because only last topic is left, okay? We'll be discussing plaster of Paris and we'll be discussing water crystallization again, okay? That's it. Any other confusion for today's class?
No.
Has this been understood? Okay.